Welcome back to my YouTube channel. Today we are going to solve GfG 160J challenge problem solving of day 18, and the problem is search pattern, that is the KMP algorithms, and the problem difficulty level is medium. So let's jump to read the problem statement. So basically we have given two strings. One is a text strings, that is txt, and the other one is the pattern string, that is pattern. And the task is to print the indexes of all the occurrences of the pattern string in the text string. So use zero based indexing while returning the indices. So there is a note also. Let's read. Return an empty list in case of no occurrences of a pattern. For example, just see like what is the example here. So for input is given like tst is abc ab, and the pattern is given ab. So we need to search that pattern in our txt, like how many times this will be available in the text. So explanation here is like the string ab occurs twice in text. One start at 0 index and the other one is index 3. So you can see here like ab is the pattern, and our strings ab is first time is like on 0 index and then 0 1 2 3. So at 3 index then again is ab. Ab is given here. So you can see the next input like abesdu, and the pattern is edu. We need to source, so we don't find here any pattern edu. So we will return just simply a empty string. Then there is a like text. We have AAB, AAC, AAD, AAB, then AB, A. So then we need to search like AA, BA. So we can find three times on 0 index, ninth index, and 12th index. Okay, so let's see the like what expected complexities we have to care about that. So time complexity should be order of n plus n m, and auxiliary space in order of m we can take it. Okay, so first we need to understand like what is kmp algorithms, right? So basically kmp algorithm is a string searching pattern, like string searching algorithm you can say, which is used to find a pattern within a large text efficiently. Unlike any this could have a naive solution also. So like we will start the beginning of the pattern after each mismatch, like pattern is given here ab, okay, and we have given a txt, so we will compare like a, and then b compare b, yes. So on 0 index we will store that 0 index. Okay, so like kmp uses the structure of the pattern to avoid redundant comparisons. If we will like if we have a given a big text and then pattern mean some length of the pattern we need to search on that in that text, then like the naive approach, if we see the naive approach, so then it will be the solution like m cross n, order of m cross n. So like every time we need to start with the 0 index if we will not find the pattern. So here we will use KMP algorithms. I will solve it. So I'm going to discuss only this one. So KMP uses the structure of the pattern to avoid the redundant comparisons. It pre-processes the pattern strings and creates an array called the longest prefix suffix. Okay. So what we need to care about that, like what is LPS. So LPS is longest prefix suffix. So let's take this example and then I will explain how we are constructing this, and then what are the approaches we are going to take for solving the this search pattern problem using the KMP algorithm. So let's jump to the what is the KMP algorithms. So I'll say like first like what is KMP algorithm. Okay, and let's say we have given a text that is a b c then a b, okay, and the pattern is named with pat, that is only ab. Okay, I'm going to take suppose red. Okay, so first we will I will pre-process this pattern strings and creates an empty array called the longest prefix suffix. What is the name? Longest prefix suffix. You can say in short form like LPS. Okay, that array which indicates like how much of the pattern can be reused after a mismatch. Suppose maybe AB is given, then AB is here, we can find that like on first attempt AB is given. If not, suppose if strings like A B C, right, then AB, okay, then our pattern is like AB, then first it will search like A, then this A, okay, this is matching, then B, no, this is not matching, right? So then again we will move the next one, I will start with the next move, and then again J with move with the first indexing. So then again A, yes, it is matching, then B, yes, it is also matching. So both this string like AB is matching with the this one. So we can find like on index 1, this is matching. So this is what means like first we will construct longest prefix suffix. So what is the idea behind it? Like how can we uh, uh, use like KMP algorithm is construct how is so like so first we will create our LPS array. Okay. So LPS array, and LPS is the longest prefix, proper prefix, which is also a suffix. Okay. So maybe you can take of this example. What is the prefix and what are the suffix? Okay. So let's take. So of this string, what is the prefix? Prefix is like A, and should it could be AB, and then A, B, C, and then A, B, C, and A again, and then the whole string A, B, C, A, B. This is the what is the suffix here? Okay. So what is this suffix? We can start with the right. We will start with the right. Suffix is like B, yes, A, yes, sorry, AB, no, sorry, B, A, B. Oh, I can rub it. This will not. Okay. So like B, then AB, then like then A B, then A and B only, and suffix strings are like C, then B C, then A B C, right? I think I took the example here. What are the example? A B C A B, and what here is A B C A B. So B, then it should be C and BC and ABC. Okay, so let's see like how we are constructing. What is the like LPS array? Then how we are constructing. So basically, we need to care about the 3 points here, and the point is like first check the point here. Like KMP pre-processes the pattern to create the LPS, like longest prefix, which is also a suffix array. Okay, and the first one we have to pre-process the pattern to create LPS. Okay. And the second was like the LPS array stores the length of the longest prefix. What is the longest prefix? Just we will store the just store the longest prefix, which is also a suffix for every prefix of the pattern. Okay, it should be suffix also, with the suffix also. And third is like in this case ABC is in matching both. When we will you will find now, then ABC and ABC. So third is like this array helps to skip unnecessary comparisons when a mismatch. If any mismatch occur, so it will skip the comparison. So like this, we can construct our LPS array for avoiding the unnecessary comparisons. So basically, we will create of LPS array for this pattern, this test only for this pattern, and then we will see like how many prefix and suffix are there, and then what is the longest prefix that is also a suffix. Then we will compare the we will helps to skip unnecessary comparison when a mismatch occur in both. So like for pre-processing the pattern, like what I mentioned in the first step. So what is the pre-processing? So for a pattern of length m, suppose we have a length of m pattern, so here is like length 2. Okay, then compute the LPS array of size m. Then we will create a LPS, that is also we will create a LPS the length of m. Suppose we have a length of m, so we will compare like this. M is 2 here. Okay, and the LPS value at any index I indicates the length of the proper prefix, which is also a suffix in the subtracting the substring pattern 0 to I. Suppose if I'm taking any like traversal on the text and traversal on the text, so for I in txt suppose, then I will consider it's like pattern, this part is 0 to I, for I in range of this length of the txt. Okay, then for searching the txt, we will compare the text and pattern characters. So basically, we will compare it. Like our pattern is this one and the text is this one. Then we will compare every time A, then B compare, then we will compare B. Okay. So if there is a mismatch after matching J, so basically I is on text traversing on the text txt, and then J is traversing on the pattern. So like if there is a mismatch after matching J, suppose here A B, and in this was not matching, like I have taken the example now that A B C A B. So A is match, yes, A is match. B, we will check if B are matching or not. So B is not matching because here on second index that is A also, A here. So like use the LPS array to decide the next position in the pattern. Okay, so like this we can create our LPS array, and then uh, our create we can create a our we can calculate our prefix and suffix. Based on that we will create first LPS, then we will compare every time like how we are. So let's I'm going to take this example, and then first I will rub everything. So I'm going to implement everything here. Okay, so let's next sheet for saving the time. So if I have a example like a txt, like a txt is A B C and A B. Okay, and the pattern is, what is our pattern, then A B. Okay, so first I will build the LPS array, and the LPS array, you know what, it helps to determine how much to shift the pattern when a mismatch occur. So first I will calculate the like length of the this that this pattern. So length of this pattern is 2, you know. Then I will construct that LPS array. Then how can we construct this LPS array? I will take the array with 0 elements and multiply with 2, that is m. Okay, and I will initialize our LPS with this one, and then I will start that index I is equal to 1. I will take a variable I, this and initialize with 1. Okay, so we don't compute LPS for the first character. So for the first character I am not taking the like LPS. So I will iterate like when I is equal to 1. So I will compare pattern of 1, and pattern of 1 is basically B. For from which I will compare? So basically I will compare pattern pattern and the length, and that character is A. So our length is 1, right? So what is my length is here, I is initialized with the 1, and length is 2 here. What is length? Length is 2. So if they will do not match, so length is 0 here, like pattern of 0. What is pattern of 0? This is A, so I have written here A. Okay, so then again LPS, what I will shift to LPS. So LPS, what will be the next LPS? For in this case, for I is equal to 1, LPS will be like LPS is will be LPS 1, and LPS 1 is 0. Okay, so what is the LPS 1 here? Like we can see like 0 and 0. So what is the LPS 1? So this is 0 indexing and this is 1, so our element is that is 0. Okay, then I will increment I is equal to plus by 1. So I will search like I by 2. So final LPS array will be like 0 and 0 again, because I is equal to 2. When I will search I is equal to 2, then it will stop the array, because we have just 0 and 1 here. And I'm skipping the first character, and I'm not taking the first index. I'm traversing the second index, that is 1. Initialize with 1. So 2 is not available, that is why it will stop here. Then I will perform the KMP search, that is step 2. So we will compare the text and the pattern using the LPS array to efficiently skip mismatch. So let's see. So length, what is the text of the length? Length of the text is either here, it is 5. Okay, and pattern is AB. So LPS array is A 0 and 0, right? So I will initialize with I is equal to 0 and j is equal to 0 for comparing whether. So let's now the perform the step 2. So step 2 is like when I is equal to 0 and j is also 0, then compare I will. So txt will compare with that is A, and pattern of 0. What is pattern of 0? Pattern of 0 is also like, what is pattern of 0? Pattern of 0 is also 0. So pattern of 0 is A, also 0. So A it match. So I will shift I is equal to 1 and j is equal to 1. So then again I will compare text 1, that is B, and that is B. Yes, that is, this is matching. Pattern is so found. So then I will I will reset J, and like J will reset LPS of J minus 1. That is LPS 1, and LPS 1 is 0. So like this, then again I will compare I is equal to true and j is equal to 0. So basically in KMP algorithm, we will not every time we will reset our j value, we will not reset I value here. Okay, why? Because we are reducting the duplicacy here. Like we will not check again and again same strings. So that is what here we are minimizing. So like this we can increment. So basically in this case, first we will find on 0, and the second is then again I will compare it. So basically A will on 3. This is on this is on 3 index, that is 0. So our result will be 0 and 3, and I will update it. So like this, now let's jump to the implementation part. How can we implement here? So yeah, let's check, and we will run our case. So first, how can we? So first I have to calculate our length, and you can say like L here, and L is suppose length is 0, I mean a slicing width. Okay, then M is equal to our length of pattern, and pattern is like our pat here. Okay, then we are constructing our LPS, and LPS should be LPS of 0 we can consider with the 0 element, or you can also consider with the length of, you can multiply with the 0 element with the length of the pattern. So and I is equal to 1, as I mentioned earlier. So while I is less than M, so if pat of I, what we are comparing? So we are comparing with the element with the length of the pattern of the length. So if is equal to pat of L, so sorry, then we will L increase by plus is by 1. Okay, and what is our LPS here? So it should be I is equal to L, that. Okay, and I will increase 1. Okay, so like this we can consider. Then like if the case, what is the case here? If the character match, so we will increase the, we will move to the next character. Like first character match, yes, match. The second character match, yes, match. Then we will increase like L also and the I also. But what if it will not match? So in that case, what are the cases here? So if we will calculate, if L is not equal to, if L is not equal to 0, then what if? So we will calculate L is equal to L and sorry, LPS, and that is L minus 1 here. Okay, and like this, then the second in this case we'll just update the length of the prefix, and to avoid redundant we are just decreasing it. Okay, otherwise else LPS of I we will update with 0, and I will increment by 1. Okay, so this is the for like this is the we are implement just constructing our LPS. This is the first case. Now what is like, what will be the our uh, so like first step is done. So just we will create here one uh, functions here. We can create, we can say like constructing LPS. Okay, so construct LPS, and we are constructing, just we are taking the pattern and our LPS. Okay, so like this. Then we will perform the search operation and we will compare it. And now after comparing, just we will implement our that construct lps in our searching. Okay, so in searchings we can say like here, we will calculate an hour length of the text first txt. And then we will compare our, sorry, we will find out our length of the pattern, that is element is pattern. Okay, and you can say like our lps we are constructing with the element 0, which how many times, m times, right? And then result, whatever, find how many occurrences, like what are the occurrences of the pattern in our text, so we will just save it in our lps. So I can take it like in here empty array. And then I perform like construct, I will call that lps and pat and txt. Okay, so then again pointers a for moving the pointers I and j, then I initialize with like I, that is like 0, and then initialize with j, that is also 0, and then I'll take a loop while I is less than n. Just here we will perform here every characters, just we will check like it is match or not. So if txt of I is equal to our pattern of j. Okay, so then it will found, if we will it will match, then it will increase by 1 for I and j also. Okay, and then if, just we will check like if j is equal to m, then we will append our result, that will be the I minus j, sorry it will be dot. Okay, I minus j, otherwise, and what will be the j, j will update by lps, that is j minus 1. Okay, so else the second case is like if j is not equal to 0, if j is not equal to 0, then j is equal to should be lps j minus 1. Again it will start with the, we will reset it. So else I plus equal to 1. Okay, and just we will return our result. Okay, okay, so let's compile and run. Okay, so construct LPS is not defined. Oh yes, because I have took here one function in our class. So basically, I have to pass self parameters here, and when I'm taking here, so I have all to self dot. Now let's compile and run. str object does not support item assignments, and that is LPS 0 is equal to 0. Let me check. So basically here I have taken earlier txt, that will be our LPS. So now let's, I hopefully it will should be run. Oh yeah. So like for input we have geeks for geeks, and we are searching geek. So basically on 0 index we can see here, on we are finding here, then on index 8. So now let's submit. We'll see like all the test cases are passing or not. So yeah, it is running. Okay, so all the test cases are successfully passed. So yeah, I hope you understand problem with the implementation also. If you will not first see the like what is the KMP algorithm. So thank you guys for today, and I will meet in the next video with the next problem. Until that, just keep learning and keep growing. Thank you. Bye bye.